Alright, so this is the second part of another video that I did on how to calculate limiting reagent. So this movie is going to be how to calculate percentage yield, and we're going to use the numbers from the last video. So during the last video we calculated what the limiting reagent was for a question, and then we found that 40.29 grams of aluminum oxide would be produced. So that is our theoretical yield. So you did this in a calculation. So if you were to use the masses of the reactants and you were to put them together in a beaker, theoretically you would get 40.29 grams. Now, if you actually did the reaction in a beaker, so you got a beaker, you put 89.6 grams of sodium oxide in it and 92.43 grams of aluminum carbonate in it, and you did this in a lab, and then you got the product, you dried it out, and then you weighed it, and the number you got on the scale was 36.9 grams, you actually did the reaction in a lab. So that would be your actual yield. Now, actual yield will always be smaller than theoretical yield. And actual yield is what you actually did. Theoretical yield is what you calculated. Now you can take these two numbers and you can put them together and you can solve for percentage yield. And the reason you do this is to see how well you did the chemical reaction. It's really rare to get an actual yield that is the same as your theoretical yield. That would be 100% percentage yield. Really rare to do that. Now the chemical formula to figure out percentage yield is actual yield over or divided by theoretical yield multiplied by 100%. Alright, so there's the information from the last slide, and we're going to do the calculation. So percentage yield, again, equals actual on top, and our actual is 36.9, divided by the theoretical, so what you calculated on the bottom, all multiplied by 100%. And in this case, it would be 91.6%. So that is how you calculate percentage yield.